Let us see how to solve the homework problems which were given in the last slide. Okay, so it was about to find the equivalent resistance across the two terminals. Okay, fine. The two terminals are here, and the arrow mark indicates where you need to find the equivalent resistance. It is saying from this end. So when these two open ends, across these two open ends, we need to find the equivalent resistance. So whenever we are given to find an equivalent resistance across 2 points, two ends, or what we call the two terminals, it is always good and is always recommended to start our analysis from the closed end. Which is the closed end here? The opposite side. This is the closed end. It's closed, completely closed. Here I don't know what 1 ohm and this 1 ohm are. We can't say whether it's series or parallel. They're not in series, they're not in parallel. But here I can see the closed end always indicates, gives us a good place to start with. It gives us the series or parallel connections. It's quite visible. We can understand it better. So it's 5 ohm, 10 ohm, 5 ohm. All of them are in series, right? So you can take it. When I say simplify this whole thing, it becomes 5 plus 10 plus 5. So this is 20. So this is a 20 which will be coming in parallel with this 20. Correct? So this 20 and 20 will be in parallel. So let's see how to solve. So this is how the circuit will look when I simplify it further. So 20, 20 in parallel and the 1 ohm will be there as usual. So again the R equivalent is across these two terminals. 20-20 parallel combination is going to give me a 10 ohm will be the 20-20 parallel combination result. And so the 10 ohm will come here these across these two terminals, and you have 1 ohm, 10 ohm and 1 ohm. So again now these two terminals are undisturbed till the end. See here these are the two terminals across which we need to find the equivalent resistance, and these two terminals are till the end the same. It's still the same two ends. We are not disturbing it at all. It's still present. That's good, and that's how it should be. And now we have 1 ohm, 10 ohm and 1 ohm in series, so we can say 1 plus 10 plus 1, so 12 ohms. 12 ohms is the equivalent resistance across these two terminals. Okay, good. Now the second one is this circuit. It's very clear that 10 and 10 are in parallel because two of the ends are connected with each other. Two ends of this 10 ohm and two ends of this 10 ohm are connected with each other, so 10 and 10 in parallel, and this parallel combination is in series with this 5 ohm. So this 10 and 10 parallel combination will give me 5 ohms, and this 5 and 5 series combination will give me 10 ohms as the equivalent resistance. So when I simplify this, I'll get 5 in series, and this 5 will become 10 because they're in series, right? Good. So we solve this R equivalent problem. Now let's see this current problem. Find I marked in the figure C using nodal analysis. Using nodal analysis, I need to say what is current I. They given the current I and the direction of current I as well. So I don't have to assume any different direction because they are given me it is flowing from the left to the right. And I just need to find the magnitude of this I. And we know nodal analysis. So let's do the nodal analysis for this circuit at this point and find what is the voltage V. So this nodal point, I'm assuming as the V. The voltage at this point, I'm assuming it as V, and I'm going to simplify it further. Here is 10 volts. 10 minus V by 2 will be the current flowing here in this branch, and I'm just assuming it's entering current, and here 3 amps, they're given the current source and it's entering again. So the current entering currents are these two. So sum of the entering currents will be equal to the sum of the leaving currents, and there's only one leaving current. That's good. So here the entering current is 10 minus V divided by 2 plus 3 amps. Entering current equal to the leaving current is V. The potential here is V minus 0. The ground here, right? V minus 0. The 1 ohm is directly connected with the ground. So V minus 0 divided by the resistance. Resistance is 1 ohm. So this is the equation, and when we solve this, we get V equal to 16 by 3. So I got the nodal voltage, but what I actually I need to find what is the current in this branch. So current in this branch is V minus 0 divided by 1. So that is V by 1, which is 16 by 3 amps again. This was in volts. This is the 16 by 3 volts present here, and the current flowing here is 16 by 3 amps. How I got to know? By using this current equation for this. What is the current here? V minus 0 divided by the resistor. Resistance is 1, so it is V by 1, 16 by 3, the same thing. Okay. Thanks for watching. Continue learning.